features that have recently been released, and just also discussing some of the new products that are on the roadmap. So Jonathan, if you could just keep track of questions, we can leave all of the questions until the end, and then we'll address answers to those questions at the very end of this webinar.
Absolutely, and we're actually thinking about, so that we don't miss any questions, we'll also be posting all questions and answers later on with a recording of this webinar as well, just to make sure that we don't miss any of the ones that come in.
Perfect. Okay, so without further ado, the 820 platform is summarized in this slide here with all of the different options depicted here with a categorization of all outdoor and split mount and all indoor. So you have a lot of different options to choose from when you are designing licensed links with Cambium. So the 820S is our single core all outdoor radio. There is absolutely no indoor footprint. It's just a single device that gets mounted outdoors up on your tower top that mounts directly to a dish, either being a radio waves or Andrews CommScope dish. Those are the two manufacturers that manufacture direct mount dishes for us. If you have a third-party dish, it's capable of interfacing to a third-party dish as well, just using a remote mount kit. So the 820S being single core is capable of achieving about 600 megabits per second full duplex. So since these are all licensed links, they do transmit and receive across a frequency pair. So generally, you will be assigned a frequency pair where you have a transmit frequency and a receive frequency at each end, either in 6, 11, 18, or 23 gigahertz. So we support all of the licensed bands, as well as higher frequency bands above that as well, and we'll talk about those. The 820C is a multi-core radio, so it has 2 transceivers instead of 1. So it's a very similar form factor to the 820S, the only difference being that it has a second antenna port, so this is capable of achieving gigabit speeds. The 820C HP is a high-power dual-core variant of the 820C, and this is capable of achieving higher transmit powers for better link reliabilities, if you were to do an apples-to-apples comparison, or just longer links, or it would allow you to cut your dish size by one size. So if an 820C met your reliability requirements with a 4-foot dish, it's possible that with an 820C HP, you could meet those requirements with a slightly smaller dish, like a 3-footer or even a 2-footer. So in some cases where you have expensive tower leases where you need to cut down on the size of your dish, the 820C HP could make a lot of sense. The 820E is an E-band radio, so this operates between 71 to 86 gigahertz, and that's capable of achieving up to 2.5 gigabits per second full duplex. The 850E is also an E-band radio. It's a newer version of the 820E, and it's capable of about 10 gigabits per second full duplex. So it's a much higher throughput, but although it's a very high throughput device, it is operating in the E-band, so you'll just have to be cognizant of the link distance that you're trying to establish for your E-band links, because with a higher frequency band, you're looking at higher free space loss and just higher restrictions on the link distances that you can deploy these links on. As far as the split mount and all indoor options go, we do have an 820G that's been out for some time now. So that supports either a split mount architecture with an RFUC, which is an all outdoor unit that mounts directly to a dish and connects to the indoor unit of the 820G through coax, so like LMR 400 or LMR 600. And then the RFUA is for all indoor applications. So this would also be a rack-mountable device containing high-powered RF transceivers, which will then connect to your dishes via waveguide. The 820S is fairly new. This is a new introduction to our portfolio, and so this has more ports, so it's capable of accommodating more RF transceivers. The 820G has either 1 or 2 RFU interfaces. It is not modular, so you do have to order the device with the appropriate amount of RFU interfaces that you desire, but it maxes out at 2. The 820F is capable of connecting up to 3 devices, and the devices that it is possible, or it's capable of connecting to, are the RFUD, which is a dual core outdoor unit. the RFU-DHP, which is just a high-powered version of that, the RFU-S, which is a single-core outdoor unit, or the RFU-E, which is an E-band outdoor unit. So in most cases, it would be supporting a split mount architecture, but what makes this so unique is that it's not communicating to those outdoor units via IF or intermediate frequency. It's actually a baseband communication, so you would be connecting to them through Cat5. So the Cat5 would be providing the PoE as well as the data and management to these devices. Okay, so diving into the product features, these are the technologies that we support with our multiband products. So that would be like the 820C, the CHP, the 820S, and the RFU-D. So going from left to right, let's cover the different differentiators and features that we support. So accelerating growth through one click, you can double your capacity by enabling the second core. So with an 820C or HP or the RFU-D, which is a dual core outdoor unit, since those are, I guess, dual core radios, they support multiband operation to where you can enable a second RF transceiver simply with just a click of a button when you are configuring the radio. So you can either enable the second core day one if you already need to achieve high throughputs of about a gig or 1.2 gigs, full duplex, or if you know that you only need about 500 or 600 megs today and you're possibly going to be needing more throughput in the future of about a gig, you can start with an 820C and not have to purchase the key for the second core activation. And once you're ready, you could then purchase the key and activate that second RF transceiver and double your capacity. So all of that would negate the need for a tower climb. You wouldn't have to have an installer install any additional hardware of maybe a second radio or an additional OMT kit or anything like that, which would be the case for any type of single core radio. So with a dual core radio, you can just enable that second core with a key and you're good to go. Also, leveraging millimeter wave capacity and microwave availability with multiband. So the 820E and the 850E, being our E-band 70 to 80 gigahertz radios, are capable of very high throughput, but at the same time, whenever it rains, it's very susceptible to rain fade just because of the very high frequencies that they operate in. So in order to improve the reliability of those links, we have what we call multiband, where you can actually connect an 820E to an 820C or an 820S in either 18 or 23 gigahertz. So those are much lower frequencies than the E-band frequencies. So they would have much higher availability. And so these 820E or 850E radios would then be performing a link aggregation down into your switch or to your router. So if there's any sort of link failure due to rain fades, it would then fall back to the 820C or S capacity in the lower frequency, which most likely would not be severely impacted by the rain as what would potentially take down an 820E or 850E radio. Increasing long-haul efficiency and flexibility. So advanced space diversity is something that we have recently introduced with 10.9. 10.9 is the latest official firmware release. You can download it from our support site. So advanced space diversity is pretty cool. It's a unique feature, and it's the ability to benefit from spatial diversity with only 3 dishes across an entire link instead of the traditional 4. So usually with space diversity, you would have 2 dishes at each end, and the diversity or secondary dish would only be receiving. And so if you had a ducting scenario that caused a link to fade on your primary link, your secondary dish, because it's physically diverse from the primary, would not necessarily be as affected by that fade because of its height difference. So reflected paths would not necessarily be as destructively interfering with the secondary dish as it was or as it could be with a primary dish, and vice versa. So that's the advantage of spatial diversity. It's something that helps improve link reliability drastically across long links, especially over reflective paths like water or desert terrain. So with advanced space diversity deployed with an 820C or 820C HP, each of these radios are actively transmitting. So with your secondary transmitter on the left side of this example, it's also transmitting a signal to the second site. So that second site with one single dish is actually, because of the phase change of the second transmission stream, is taking up an additional 6 dB of gain with advanced phase diversity. And then on the other end is just your traditional spatial diversity, because you've got two transceivers that are also receiving the same stream of information from the right-hand side. So if there is any sort of fading scenario, one of those would always be active. And also, it's not a situation where an indoor unit is choosing the best signal. Both receivers are they're actively receiving, and they're actually combining each symbol in the baseband. So you're actually improving your overall signal by about 3 dB because of that doubling of that signal. 4x4 line of sight Mimo. So this is something that we've always had. Initially it was unique, but I think some of our other competitors also have this feature now. So this is just the ability to reuse a frequency pair across 4 transceivers. So being able to reuse a frequency pair across 2 transceivers is pretty common. That's known as XPIC. But here with 4x4 line of sight Mimo, you're doing it across 4 transceivers, so you're actually using 2 separate radios on each end, 2 dishes on each end, and so it's sort of like XPIC times 2. So in a 30 megahertz channel, you're actually able to achieve about a gig full duplex, which is a very high spectral efficiency because of this technology. So this is something that could be deployed in areas where you need very high throughput, but are not able to get enough spectrum for your high throughput link. Also, the ability to reuse frequencies, again, in spectrally congested areas where your frequency coordinator may tell you that it's not possible to be able to achieve a link with advanced frequency reuse that may help in certain cases. So in this example, you have one location that's talking to 2 sites. So in this location on the left, that could be an 820C or an 820C HP that connects in an east-west configuration where it's actually remotely connecting to 2 dishes. And then on the other ends, on the right side, you could have 820S radios that are tail sites for advanced frequency reuse that can potentially reuse the same frequency in a very small azimuth delta or difference. So typically, before a frequency coordinator can reuse a frequency pair, they would usually need about 90 to 120 degrees of angular separation. So whether it's using a Cat A dish or a Cat B1 or Cat B2 dish, that's what would dictate the angular separation requirements. So about 90 to 120 plus degrees before you could reuse a frequency. So if there's frequency congestion and the frequency coordinator is able to find one frequency pair, but another link is maybe 30 degrees away, but you can't find a frequency pair for that, it's possible that with frequency reuse, because of this technology, the frequency coordinator could then reuse that available frequency on the other link as well, as long as you have enough angular separation, which is a much smaller requirement with advanced frequency reuse. So those are the technologies that we offer with the 820 product line. So let's now take a closer look at each of the different devices in the platform. So the 820C, again, is an all-outdoor dual-core radio. So this operates from 6 to 38 gigahertz. It achieves up to 2048 QAM and supports up to 80 megahertz channel sizes. So this is about 1.2 gigabits per second full duplex. One thing to point out is that release 10.9, again, the latest official release on our support site, does now support 2048 QAM in an 80 megahertz channel. So before, with wideband radios operating in 80 megahertz channels, profile 8, which was 1024 QAM, that was the highest profile and the highest modulation mode that was supported. But today we do support a full 2048 QAM in a full 80 megahertz channel, which is about a 6% improvement over 1024 QAM in the same channel size. As far as configurations go, we do support 1+0, which is single core, 2+0 as well, which is it just requires the second core activation key. 4+0 is basically 2 times 2+0, so it's a setup where you have 2 820Cs combined together through a dual splitter or a dual coupler. We do support XPIC through the 820C. This, for those of you who aren't familiar with XPIC, stands for cross-polarization interference cancellation. So this is where you're reusing a frequency pair in both polarizations of vertical and horizontal polarizations in order to improve your spectral efficiency and be able to double your capacity with just one single frequency pair. We do support hot standby as well, either 1+1 or 2+2, as well as east-west, which is a configuration for advanced frequency reuse, where you would remotely connect to 2 separate dishes pointing in 2 different directions. We also support multiband, where it would then interface to an 820E or 850E to basically improve the reliability of that E-band radio. As far as capabilities go, it does support 4x4 line-of-sight Mimo, as well as advanced frequency reuse, and it doesn't show advanced spatial diversity, but it does support advanced spatial diversity as well. So these are the different interfaces for the 820C radio. So the very bottom of the radio, going from left to right, has an external DC port for DC power. It does accept negative 48 volts DC, and then 3 Ethernet ports. These are all gigabit Ethernet ports, so they're capable of gigabit speeds. So the first Ethernet port is a copper RJ45 port, and the next 2 are SFP ports. So they could be used for user traffic, or I guess 4x4 line-of-sight MIMO, which is a pretty special and unique case, via Ethernet 3. The last port is the management port. So this is for out-of-band management. Some operators like keeping the management traffic physically separate from their user traffic. So you would do that by deploying a separate Cat5 cable, running management. This is the default port for accessing the 820C or S or any other 820 radio. So when you first power it up, either through external DC power or through PoE into Ethernet 1, you do have to access it through the management port. And if you do desire in-band management, then you would have to configure it accordingly. So the front of the radio contains the antenna ports. As you can see here, these are the 2 antenna ports. So in order for the antenna ports to interface to a dish directly through direct mount, you would have to interface through some sort of a mediation kit. So that could be an OMT, which is an orthogonal mount kit, or a splitter. And then on the very back of the radio, you have your RSL indication, which is basically a BNC port. So a technician could connect a voltmeter or a multimeter to this port to measure the voltage. The cool thing about this is that the voltage readout, the last 2 decimals correspond directly to the received signal level. So if it's 1.56 volts, then that corresponds to negative 56 dBm received signal level. So it's nice because the technician doesn't have to carry up a table, a lookup table, to determine what sort of receive level he's getting based on the voltage. And these are the different multi-core configurations that are supported. So 2+0 dual pole would involve a mediation kit called an OMT. So again, this is the orthogonal mount transducer kit. So this would take both of the antenna ports and combine them, making them orthogonal to each other before interfacing to a single pole dish. One other thing to add is that RadioWaves and CommScope manufacture single pole dishes for all of our 820s. So sometimes this can be a little bit confusing because if you're doing 2+0 XPIC or 2+0 cross pole, where you're transmitting and receiving over the vertical and horizontal polarizations, you would expect a dual pole dish, but that is not the case. So the single pole dishes that we have are circularly polarized, so they do support V and H through one single waveguide flange. So in this case of dual pole, the OMT is taking both antenna ports, which you're not going to configure through software or manipulate through hardware. They're just fixed. They would take, or the OMT would take both of those ports, make them orthogonal to each other, and then interface directly to the single pole dish. In the case of 4+0, whether it's single or dual polarization, that would dictate whether you're using an OMT or a splitter. So if it's dual pole, you would use an OMT. If it's single pole, you would use a splitter because you're basically wanting to combine the signals into the dish, but from the dish, you're splitting those signals out into the different 820Cs. And then from there, you would have a dual coupler or a dual splitter. So the dual coupler would have higher loss on the secondary side than it would on the primary side, which makes sense for a hot standby scenario where you want to optimize the performance for the primary radio. And the dual splitter would have equal losses on the primary side as it would on the secondary side. So that's something that you would want to deploy for 4+0, because with 4+0, all of your cores are active all of the time, so you would want to balance the paths so that all of the transceivers have the same receive signal levels. So with the dual splitter, you're typically looking at about 3.5 or so dB of loss on both sides. With a dual coupler, it's usually about 1.5 dB of loss on the primary side and roughly 6 to 6.5 dB of loss on the secondary side. So even though it seems kind of complicated, it is pretty straightforward. So again, you would use an OMT kit for a dual pole setup, or a splitter if it's all single pole, where all of the RF cores are vertically polarized or they're all horizontally polarized. And then from there, in order to interface two 820Cs together into one OMT or one splitter kit, you would need a dual coupler for hot standby or a dual splitter for 4+0. Okay, and then for 4x4 line of sight MIMO, this is the case where you need to achieve very high throughput and a limited channel size. So in this case, you would have 2 dishes on each end, along with 2 radios as well, with each radio interfacing to its own dish. And then from there, each 820C would be sharing one single frequency pair. And so they would communicate via source sharing cables, and then they would connect to a switch or a router down in the shelter down below. So the 820C HP is very similar to the 820C. Performance-wise, it's very similar. The only difference is that it is a high-power radio, so it's capable of 5 dB or more transmit power than the 820C. So this is capable of up to about 35 dBm of transmit power, which is very high. I believe that's close to about 4 watts. This is only available in 6 or 11 gigahertz, so it's not available in 18 or higher. It is capable of 2048 QAM up to an 80 megahertz channel size, so about 1.2 gigs full duplex, just like the 820C, but again with higher transmit power. So here are situations where you need to be cognizant of dish size, where maybe your tower lease is expensive, or the tower is pretty close to capacity, and the structural analysis sort of limits you in dish size. You may have no choice but to use an 820C HP so that you can overcome the difference in dish gain with a smaller dish with the higher transmit power of the 820C HP. So the configurations that are supported are 1+0, 2+0. It does support XPIC as well as hot standby. And the other differentiator between the CHP and the C is not only higher transmit power, but it's also field replaceable diplexers. So this is really nice because it helps to keep spares to a minimum. So with the 820C and the 820S, those do not support field replaceable diplexers, and they're all subband based. So in 6 gigahertz, we do have several subbands. I think it may be 3. In 11 gigahertz, we do have several subbands as well, and maybe 4 or 5. So whenever you're assigned a frequency pair, it's usually, or it is, subband specific. So if you're assigned maybe 3 different subbands across your entire network and you're stocking spares, you would essentially have to stock 6 spare radios, a transmit high and a transmit low for each of the 3 subbands that you were assigned frequency pairs in. However, with 820C HP supporting field replaceable diplexers, you could just stock one single radio, and that radio can interface to any diplexer, which is also subband specific. So you could have, I guess, 6 different diplexers, but would only have to stock one radio. So this would keep spares to a minimum, as well as the cost for spares. It will keep that cost down. Capabilities include line of sight 4x4 MIMO as well, advanced frequency reuse, And also, it's not showing it in this slide, but advanced space diversity. So this shows, I guess, a blown-up diagram of the 820C HP radio separated from the field replaceable diplexers. So as you can see from the illustration to the left, that's looking at the insides of the diplexer, so you can see the field branching units. And then the back of the 820C HP radio is what you're seeing here. And then on the right side, it's basically that same illustration, but flipped. So on the left side of the right illustration, this would be the field replaceable diplexers. And then on the right side, that is your 820C HP radio. So looking at the different options that we have for branching, so not only do we have field replaceable diplexers, but we also have channel filters. So channel filters have lower loss compared to diplexers, but they also have much more stringent requirements for frequencies. It has a tighter frequency response. I believe in some cases it may also require frequency tuning in the factory. So this is not going to be very common for your typical 2+0 or 2 times 2+0, also known as 4+0 deployments. It's more for 8+0 and 16+0 deployments, and we'll cover that in the very next slide. But again, these illustrations are just showing what they look like and how they would be connecting to each other with the 820C HP or RFUD HP, which is the split mount that's supported by the 820F, connecting to these filters or diplexers. So this is the illustration that depicts the 16+0 support that we have for very high throughput applications. So on the left side, you have your radio unit. And so if it's a direct mount type deployment, usually that would involve diplexers, like field replaceable diplexers, and your typical hardware that we normally deal with. But if you need to deploy something that exceeds 2 times 2+0, also known as 4+0, like 8+0 or 12+0 or 16+0, that would involve filters. So these are filters that may need to get factory tuned. We do have fairly strict requirements on the frequencies that are supported. So if any of you guys have a need for very high throughput that exceeds a typical 4+0, which would be delivering about 2.5 gigabits per second full duplex in either 6 or 11 gigahertz, let us know and we can work with you guys. So we could support up to 4 times 2.5 gigs. So that's basically about 10 gigabits per second full duplex in 6 or 11 gigahertz. So if you're able to have access to enough spectrum and have very high throughput needs, this is something that we can achieve with the 820C HP or RFUD HP, along with some fairly unique branching technology, which would minimize the losses and allow for something as crazy as 16+0. Because if you were to use the typical hardware of today, something like 16+0 would cut your signal in half once by going from 2+0 to 4+0, the second time going to 8+0, and then a third time going to 16+0. So essentially that would be about 9 dB of loss on each end, because the transmitters have to go through that, as well as your other end that's receiving. So that's about 18 dB of loss total, which sort of precludes even the possibility of doing something like this with traditional hardware just because of so much loss, even if you did have a fairly short link. But with the new filtering technology, we can support it because of the very low loss. The 820S being single core has very similar stats when you compare it to the 820C. The only difference is that it's a single core radio versus a dual core radio. So with one single RF transceiver, it only supports 1+0 or 2+0, which would be 2 separate 820S units, or 1+1 hot standby, which would also be a physically separate redundant unit. So it will support 2048 QAM and an 80 megahertz channel as well, which will allow it to achieve about 600 megabits per second full duplex. As far as capabilities go, it does not support XBIC. It does not support advanced spatial advanced space diversity. It does support advanced frequency reuse, but only as a tail site, and it does not support 4x4 line of sight MIMO. So a lot of the capabilities that the 820C and HP do support, the S does not support just because it's a single core radio, so inherently a lot of those other technologies that we discussed are dual core technologies. So the interfaces are very similar to the 820C interfaces. In fact, they're identical. The only difference is that you have one antenna port now versus the second antenna port, but as far as the user ports go, you do have that same external DC port, the gigabit Ethernet ports with a PoE, Cat5 RJ45 port, 2 Qsfp ports, and an out-of-band management port. The configurations are a lot more straightforward. So 1+0 direct mount does not require a mediation kit like an OMT or splitter kit or anything like that. You would essentially just bolt the 820S directly to the single pole dish, and you would be done. The only thing that you would have to ensure is that the polarization of that single pole dish does match up with the polarization of your 820S. So in most cases, vertical polarization is the most commonly assigned polarization for a frequency pair. But if you do get assigned horizontal polarization, then you would have to change the polarizations on both the radio as well as the dish, because they do ship vertically polarized by default. 1+1 direct mount is hot standby, so that would involve two 820S radios connecting to a coupler. And if it's 2+0 you want to achieve with two separate 820Ss, then that would be going either to an OMT kit for dual polarization or a splitter for single polarization. And so again, we would support copole or cross-pole links, but not XFIC links with 820S. If you do have an XFIC link, that does mandate the use of 820C or CHP or DHP, just not 820S. The 820E, so this is the E-band radio. So this operates from 71 to 86 gigahertz. This supports up to 1024 QAM and up to a 500 megahertz channel size. So based on those stats, this will cap out at about 2.5 gigabits per second full duplex. There are a couple of options here for the 820E. There's an ESS version and an ESP version. The next slide will go into the differences in more detail, but the ESS is basically, it's a gigabit version, so that's capable of up to a gig full duplex of user traffic. The ESP is an SFP+, so that's capable of 2.5 gigs. As far as configuration support goes, it's 1+0, so there's no 2+0 support, there's no XFIC support. If you do need that for higher throughput, you would have to go with the 850E. We'll get into that in more detail. It does have an SFP+ port for the ESP version, so you do have to make sure that you order the correct 820E model if that's what you desire. Both ESS versions and the ESP version support multiband, but if you do need multiband, you should be going with the ESP, and we'll talk about that. So on the bottom right, it shows the high capacity of the 820E. So based on the channel size and the modulation modes, this is how much throughput you could expect to achieve in the different channel sizes and modulation modes. So in a 62.5 megahertz channel size, you'd be getting about 500 megs full duplex at 1K QAM. And then, of course, as you get into the larger channel sizes, it is delivering higher throughput, although it's not capable of achieving the same 1K QAM modulation mode in all of those larger channel sizes. But even at 64 QAM and a 500 megahertz channel size, it is capable of achieving 2.5 gigs full duplex. Okay, so this is the physical description, and this is what's going to break down the difference between ESE and ESP. Sorry, I may have said ESS earlier. So the E stands for Ethernet, the S stands for SFP, and here in this case, because the third port is SFP+, the P stands for SFP+. So port 1 is a gigabit copper RJ45 port. So this is for PoE and user traffic potentially in the case of ESE, or it could be used for out-of-band management in the case of ESP. They both say external DC option. I'm not entirely sure what that means. It sounds like it could mean that there's an option to where instead of being a copper RJ45 port, it's actually an external DC port, but I'm not entirely sure. If anyone has any desire for that, let me know and we can discuss that offline. Port 2 is an SFP port. This is a regular SFP gigabit port. And then the third port is usually what would be used for user traffic if it is an ESP radio, because this is the SFP plus port, which is capable of 10 gigs full duplex communication. Whereas in the ESC version, it's just I think that would be a typical gigabit copper Cat5 port, if I'm not mistaken. The external port does not serve a purpose today. We do plan to use this in the future, potentially for XPIC or hot standby, but today we do not support either of those, either through the external port or over the air. There is no XPIC or hot standby that's supported over the RF link. So these are the different deployment scenarios. So we do have dishes for direct mount of the 820E connectorized, or we also support an 820E with an integrated dish, and that is a 43 dBi integrated antenna. If you guys are interested, I could probably find the spec sheet on that integrated antenna just to see what the radiation pattern is like. It potentially could have a wider radiation pattern than a dish, which could make it easier to align. So 820 multiband is, it's just I guess it's a concept of the ability to combine an E-band radio with a lower frequency 820S or C in order to improve the overall reliability of that link. So again, because it's E-band, it's such a high frequency, so it is much more susceptible to rain fades than lower frequency licensed bands like 18 or 23. And in most cases, because it is E-band, you would not be deploying this over very long distances. But even at 1+ miles, you could have a rain fade fairly often with 820E, just because it's the nature of the E-band. However, with those link distances, that is relatively short for an 18 or 23 gigahertz frequency, which would most likely maintain the availability of that link. So if you're using an 820S for multiband, that's capable of 600 megs full duplex. So if the 820E were to fade out, that would fall back to the 820S, which would maintain the link. Although it would sacrifice the throughput, it would still maintain the link. But if you use an 820C in this multiband deployment with an 820E, and you have the second core activated, this would then be capable of 1.2 gigs full duplex. So whatever capacity you lose through the 820E would then fall back onto the 820C. So looking at the, I guess the illustration of parts on the bottom left, here you have the 820E radio, which interfaces to, I guess, a special mediation kit that allows the 820E to interface to the dish with a side connection for the 820C or S. So if it's an 820C, it would still have to go through a mediation kit of an OMT if it was dual pole or XPIC, or a splitter if it was copol, maybe 2+0 in the vertical polarization or the horizontal polarization. If it was an 820S, it would mount directly to this side connection. And so on the right here, you can see the cable connections. And so the 820C or S would connect via either of the user data ports. That could be port 1 or port 2. If you're running PoE, you would most likely have to use port 2 because port 1 would be used for power. And then from there, you would connect to one of the 820E user ports, and then you would connect the SFP plus port if it was ESP, or any of the user ports if it's ESD. And then from there, you would connect down into your switch or to your router. So for the multiband deployment, it would most likely make sense to use an 820E ESP because that's capable of 2.5 gigs. If you use an ESE, you're capping yourself at a gig. So the ESP would make a whole lot more sense. So this just shows the capacity as a function of availability. over the different nines of availability. So if it's a clear sunny day and you're getting very high receive signal levels, you're going to be achieving 2.5 gigs full duplex. So this is going to be the entire capacity of the 820E E-band radio. However, if it drops down to maybe 3 nines and a 6, to where you start getting some rain, some drizzle, then that link, that 820E link, is going to fade, although the 820C or S link would likely not be impacted. And as that drizzle turns into rain and it turns into a downpour, that's where you get into situations where the receive level drops severely enough to where the 820E can drop out completely. However, if you're not expecting high throughput all of the time, you would be getting more reliability as your throughput decreases, right? So here you could get 5 nines at a lower modulation modes, just because you do have that 820C microwave link as a backup. Okay, so 850 all outdoor. I only have slides for 850E because that should be available fairly soon. The 850C is a 2020 roadmap item, so it's still a ways out. So I'm not going to talk about that since it's pretty distant in the future. But the 850E is our E-band radio that's capable of 10 gigs. So the 820E supports up to, I believe it was a 250 megahertz channel size. So because of that, it caps out at about 2.5 gigs. Maybe it's 500 megs. Maybe it was 500 megahertz as a channel size. I can't recall. But the 850E does support much larger channel sizes. So it does support 250 megahertz, 500 megahertz, as well as 1 and 2 gigahertz channel sizes. So it's very wideband and supports much wider channel sizes than the 820E. So this is something that you could deploy if you have very high throughput requirements and a fairly short link that's capable of accommodating a fairly reliable connection over such large channel sizes. So using a single cable, this is capable of 20 gigs full duplex over layer 1 link aggregation. That is a pretty unique interface. It's Qsfp. I have not seen that before, but I've heard that Cisco and Juniper do manufacture switches and or routers that have Qsfp interfaces. So if you're going to deploy the 850E, that's another aspect to be cognizant of, because you do have to make sure that you have hardware and equipment at your sites in order to even be able to connect to the 850E. This does have multiband support as well, so that's the same concept as before with the 820E multiband. And these are the different interfaces for the 850E. So going from left to right, you have an external DC port. The second port is a copper Cat5 port, so this could be used for PoE or out-of-band management. And then port 3 is an SFP port that will support gig or 10 gig speed, so it looks like it's actually SFP+. The fourth port is the Qsfp port, so typically you would be using this port if you were to use an 850E, because the whole point would be to get that 10 gigs or more, so you would be using this Qsfp port. Port 5 is just your traditional SFP, which is a gig interface, and then port 6 is an external connection, which could be used as a technician port. And so the illustration on the bottom right just shows the different hardware or ancillary items that could be used in support of the 850E. So this would be the integrated dish connected to a pipe mast on the left. The middle is just a direct mount to an external dish. And then on the bottom right, that's 2 850Es connecting together, either to an OMT or to a splitter kit. So the 850E does support 2+0. So that could be 2+0 single pole or cross pole, or even XPIC. We do have XPIC support for the 850E to where you would be utilizing the same frequency pair across both polarizations. Again, we do have multiband support. So that would be an 850E that connects to an 850C, and then from there you would be connecting to the router. Again, I don't have any slides on 850C, but it does say here in the bottom right that we would support the 820C as well. So that could also be an alternative for a multiband deployment. Split mount and all indoor. So the 820G is the split mount IDU or indoor unit. This does support the typical frequency range of 6 to 38 gigahertz, 2048 QAM, and up to 60 megahertz. So that's something to be aware of. It does not support 80 megahertz. This is a hybrid radio, so it supports Ethernet interfaces as well as TDM. So for those of you who may still be deploying T1 circuits, the 820G would be the appropriate radio to deploy for those T1 interfaces. Configurations that are supported include hot standby, 1+0, 2+0, and 1+1 hot standby with spatial diversity. Capabilities include a fully redundant configuration. So not only does a single 820G support hot standby with 2 different RFUs, it does support the ability to connect to a secondary 820G, and you could then use splitter cables to connect from the user ports to a switch or router or DFX channel bank in the case of T1s, to where you have full redundancy and truly hot standby behavior. And so these are the different interfaces of the 820G. There's a high density MULX port for T1s, DB9 port for external alarms, and then Cat5 ports for T1 reference clock, management, a craft port, 4 gigabit user ports, and 2 SFP ports, and then 2 RFU interfaces. So we do have 4 different options for the 820G, 1 or 2 radio ports, as well as with or without T1s. And then at the far right, you do have redundant power feeds. The 820G supports split mount or all indoor. So split mount would be supported with an RFU-C, which is the outdoor unit, or an RFU-A for the case of all indoor applications where you would then run waveguide. The 820C, the RFU-C is pretty standard. It's just an outdoor unit. All of these specs are pretty similar to an 820S, just that it is split mount and it does only support up to 60 megahertz channel sizes. The RFU-A is the all-indoor RF transceiver, so this is rack mountable, and then from here you would be connecting to waveguide that would then connect to the antennas. The RFU-AE is a high-power device of up to 32 dBm. The AEP is enhanced power of up to 34 dBm. And this is just showing, I guess, the parts within the RFU-A. You have your branching drawer, your output expansion ports, as well as your RFU transceivers, which all comprise the RFU-A that then connects via waveguide to your antennas. 820F, so this is already shipping today. So this is also split mount, but again, this is fairly unique split mount because instead of connecting to the outdoor units via coax or LMR via intermediate frequency, it is actually using baseband. So you can then connect to the outdoor units via Cat5 or Cat5e or Cat6. So to the tower climber, it would be just like an all outdoor deployment, but instead of connecting it to a PoE injector that then goes to your switch, you would just be running this down into your rack, which would connect to your 820F. But still, you wouldn't be having to deal with IF cable or LMR. So this does support 6 to 86 gigahertz because this does support the E-band. It supports 4K QAM or 4096 QAM, 80 or 112 megahertz channel sizes as the largest channel sizes. I believe 112 is more for ETSI. It's not something that we're going to see here in North America. So this is capable of 2.5 gigs full duplex of user throughput, which would then connect to a switch or to a router. Interfaces include gigabit ports, SFP+, T1s, as well as STM1 and OC3. That's on the roadmap. So for configurations, we do support 1+0, 2+0, MC-ABC, as well as 3 times 1+0, because it does have 3 baseband ports that would connect to the different ODUs. It also does support full redundancy and no single points of failure. And so these are the different ODUs that are compatible with the 820F. RFU-S is a single core outdoor unit. RFU-D is a dual core outdoor unit, which would interface to the 820F via a single Cat5 line. The RFU-D HP is a high power version of the RFU-D, so this is dual core. And then RFU-E for E-band links that would then connect to the 820F. All right, so that covers everything. So we covered all of the devices in our 820 license portfolio, as well as the latest features. Any questions, Jonathan? Did we capture any questions that I can go over answers for?
Hi, Brian. Actually, we didn't get too many questions come in, but if anyone comes up with any questions after the fact, please send them over to sales@ispsupplies.com, and we'll make sure that we get them answered. And we will be posting also all of our questions and answers along with a copy of this webinar. So make sure that you subscribe to us on Facebook at facebook.com/ispsupplies, and also follow us on our YouTube channel for a copy of this webinar and all of our future webinars as well. Do you have anything else to cover, Brian?
No, that's it. Thank you, everyone.
Okay. Well, thank you so very much for taking the time to go over all those 820 radios in such detail. And if anyone has a link that you're looking into licensing, please send over the GPS coordinates, site names, antenna heights, and the desired throughput over to sales@ispsupplies.com for a complimentary path analysis and quote. So we would like to thank everyone for joining us today. Wishing everyone a wonderful weekend, and thank you all. God bless. Bye-bye.
Thanks all. Bye.
Thanks.